Hi, I'm Kaylee Shacklock, and this is Lab 5, Choose Your Own Adventure. My adventure for this lab, I decided to focus on the moments of inertia, more specifically downhill racing. Introduction. Focus. The focus was to determine the types of relationships that mass, radius, incline, and gravity have on a moment of inertia. Purpose. To determine whether these relationships are directly proportional, inversely proportional, or have no direct relation at all. Main physics idea. Moment of inertia of certain shapes, more specifically solid sphere, solid cylinder, and another solid cylinder with its axis turned. The parallel axis theorem, which states that the axis of the moment of inertia is known, and the parallel axis through the center is equal to the above equation. And final velocity, downhill racing, more specifically. Brief introduction. Mass and radius have no direct impact on final velocity, but height and gravity are directly proportional to the final velocity. Lab. Use the created code to determine what the final velocity will be after mass is altered while everything else remains the same, both on cylinder and the sphere. Use the code to alter radius while other variables remain the same. Use the code to alter incline of ramp while other variables remain the same. Graph velocities for both cylinders and spheres. Compare. The code for this sphere is just a breakdown of the previous mentioned equation for the moment of inertia for the sphere. You can see we have all the variables such as gravity, height, length. We also have mass, radius, and the overall equation for its moment of inertia right here. This is what the code looked like before and after it was ran. The system here is a sphere, and the surroundings of the ramp and everything else. Initial conditions is that it starts at zero velocity and starts at the top of the ramp. Very similar for the cylinder, almost the same code other than the moment of inertia is altered just a little bit. Data. This is the data for velocity change with mass. We can see that for this graph, there appears to be no change as far as the final velocity. The data shown determines that the mass of an object does not impact the final velocity of the given object at the end of the downhill race. There is no clear relation, but why? This is because in the equation of final velocity, mass cancels out, leaving no relation. This is as the height changes or the incline. You can see that they're both steadily increasing. What does this mean? The data shows that there is a direct correlation between the final velocity and the height of the ramp. As the ramp increases in height, so does the final velocity. The relation is directly proportional because as the height of the ramp increases, so does the final velocity. But why? In the equation for downhill racing for final velocity, height is not canceled out in the equation and has significant impact on the overall velocity. This is velocity as radius increases, very similar to that of the mass. What does this mean? The data shown determines that the radius of an object does not impact the final velocity of the given object at the end of the downhill race. Relation, there is no clear relation, but why? This is because in the equation of final velocity, radius cancels out, leaving no relation. Velocity versus gravity, very similar to the velocity versus height. What does this mean? The data shows that there is a direct correlation between the final velocity and gravity. As gravity increases in height, so does final velocity. Relation is directly proportional, but why? In the equation for downhill racing for final velocity, gravity is not canceled out in the equation and has significant impact on the overall velocity. What if? What if friction was a factor? As you can see in my code, friction was not a factor at all. I tried to work on it, but I couldn't exactly get it right. In this experiment, ideal factors were chosen to demonstrate according to the material we learned in lecture. If friction was introduced as a factor, then the final velocity would decrease as there is a resistant factor introduced. Possible errors. Like I said, friction was not incorporated. This was an entirely computational experiment, so meaning that I didn't have any real-world data to kind of compare it to. And the coding may have been off since I did write it. Conclusion, mass and radius have no direct impact on final velocity, but height and gravity are directly proportional to the final velocity.